Okay, so that brings us to the first problem where we, no, not actually, here up here. Fine. So exercise 10.1, where we get to look a bit on inheritance. So this is a bit of a technical application to inheritance, but what we basically want to do is that we are familiar with we're familiar with the regular strings. So like we can create a string that looks like this, and then we can do stuff. Oops, we can't do it like that. We need to start Python first. Here's a string like hello. And now we can do stuff like putting it all in lowercase or putting it all in uppercase, for instance. But what if we wanted to add a new method here that we could call like do funky stuff? And we just want this to work. We want when I call this method, it should return a new string of some sort. With implement some functionality that's not found in our regular string class. And we can actually do that with inheritance, and that's what the example will show us. And the specific functionality we want is this to snake case function. So what we should be able to do is we should be able to create a string like this. This is not the same text, and now text should behave like a string. So it should behave like a string in the sense that S behaves like a string here, because it is a string. So we should be able to use the split method and the lower method and all that, but we should also be able to call this new toSnake case method that converts this string to snake case and prints it and returns it. So we'll do that with inheritance. And what file are we going to look at? Going to look at the file extended string. Okay, cool. Okay, so let's try to do that. So first of all, like this syntax, that looks a little bit weird. But maybe it's not that weird, because this built-in string is actually a class. So when I can create a new string by just using this syntax, but that's just a convenience in Python. I could actually also create a string using this syntax. Hello. And that would be another way of creating a string. So string is a class to begin with, and that means that I can, when I write my extended string and extend it like that, I'll be able to actually instantiate this extended string class by just doing this stuff. That's already supposed to work. So let's just test that it actually works by extended string, by just creating an example, hello world, and then do print es.lower, for instance. No, not like this, of course, extended string. Like this. Let's insert a breakpoint here. Now we can see that first of all, look at the terminal. It prints out what we expect. Prints out hello world, like we just put this in lowercase. And we can see that if we go into the console and check what type ES is, we can see that it's a class of type extended string, as we would expect. But since we inherit from string, it has all the methods from the regular string class. Okay, so actually extending this is quite simple. We just implement this def to snake case like this. And now we need, let's insert another breakpoint here, and then print out an example. So let's just do the example that we have in the text. Like this. And now I insert a breakpoint here in the function because I want to sort of examine what I have available and implement it iteratively. So let's remove this example, and now we'll see what happens when we call our function that we still haven't completely implemented up here. So I'll just run this in the debugger. Then it'll hit this, call the function here, hit this breakpoint, and the Python interpreter will stop. So now we in order to implement this method, I need to get access to this variable. I need to know how it's stored. So let's see. I think I can just do like this, because this is going to convert the class to a string. It's a little bit obtuse, so that's why I wanted to insert a breakpoint and examine it. But remember that you can use the string method to get string representations of different objects, including the object itself, although it happens to be a string. Like you can do string of 23 and it'll convert it to a string. So that would be one way of getting access to this string. It's a little bit of obtuse and tricky, but that is, I think, the simplest way of solving it. And yeah, it basically relies a bit on getting a good idea, I'd have to admit. Now let's actually convert this to snake case. So that's fortunately simple. So we first put it into lowercase. Let's just test it down here. Now it's lowercase, so that's fine. And then we can replace spaces with underscore, which was the second thing we needed to do. And now it looks better. And I wonder if I should remove the period. I don't think I should. So now we have the right string and we can return it. And that should actually do the trick. So let's quit and try to run this. And that didn't work really well. Oh, that's because I'm in the Python interpreter. So the three greater than or equal sign, greater than signs. Now it works. Okay, so let's try to check the test and see if it works. This is a little confusing. Inventory, item, snake case. Okay. Yeah. So it's a bit of an obtuse example, and I think this is maybe slightly tricky, that we needed to get this good idea that we could get access to the string that we called the constructor with by using the string method. But well, it works. So that's fine. But this part about how you could override a function, that part is I think a fairly straightforward application of class inheritance. And you could do this with all the built-in data types if you wanted. You could do it with lists and dictionary and extend them in all sorts of weird and wonderful way. I would maybe not recommend doing it. This is a bit of a toy example because it can be super confusing that you have something that is a string, but it can also do some other weird stuff. I tend to use class inheritance more when I build my own classes. I have to say, but as an example, I think it's pretty cool. So I think I'll end the video here, and let me see if I can pause it.